The world has changed, and the skill set that's going to be most important for the 21st century is not the same skill set as the one that we created in the 1950s.
Maybe the way to try to drive some change in engineering education is by actually starting a new college completely from scratch.
Olin's an engineering school where you understand that there's a fundamentally different definition of engineering. It's about deeply understanding the world and what it needs.
So the way to think of Olin is it's not actually a college, it's a form of national laboratory.
We have a lot less lecture and a lot less of the student sits here and the professor sits here and knowledge flows this direction.
Just sitting there watching someone draw stuff or write stuff on the board and you copy it down and you call it a day, it never quite works for me. We're trying to develop a fully autonomous robotic fish that is capable of crossing the Atlantic Ocean using a propulsion method that is entirely based on biological fish. I have to solve my own problems. I have to figure out what I need to know. I have to go find that knowledge and then apply it. It sticks around for a lot longer.
So rather than listening to how it could be done, you actually do it and experience it.
Before I came, the 50-50 split wasn't really a thing I realized I cared about. And then I got here and I realized how much I liked having other women around.
The entrepreneurial mindset really is threaded through the curriculum, and we've seen really successful student groups who have spun off a small company while they've been at Olin as they've left Olin.
Scope is our senior capstone project.
We bring in companies from outside with real problems, and then the Olin students examine the problem, come up with a solution. The companies love it. We have more companies knocking on our door than we can possibly fit in the program.
Employers tell us it's as if they have 3 to 5 years of experience when they leave, because they actually have 3 to 5 years of experience when they leave.
Senior executives require employability skills, digital fluency, and innovation science. And Olin students are graduating with those skills. It's truly differentiating.
The number of places our students go and the number of organizations that want them is, I think, all the evidence you need that we must be doing something right.
About 40% of Olin's alumni so far have continued on to graduate work. About 25% of the kids who continue on go to either Harvard, Stanford, or MIT. The National Academy of Engineering created a list of what they call the grand challenges, 14 problems that we will have to solve in order to continue life as we expect it.
There are critical problems to solve. They have substantial technical components, but they also have really critical economic, political, social components. We have a large fraction of our students that are doing the Grand Challenge Scholars Program.
Both here in the United States and overseas, more and more people are looking at Olin as a model for the future.
Our job isn't just to come up with a new recipe to teach engineering, it's to give that recipe away to anybody who wants it.
At present, we probably have about 3 institutions visiting a week.
Schools like the University of Illinois, like the University of Texas at El Paso, like Delft University.
Olin is doing enormously powerful work with other institutions in the world. By investing in Olin, you're making a difference in education on a very broad scale.
My disciplinary field is material science, and so I teach both introductory material science courses, and then I teach advanced courses at the intersection of biology and material science. That's what my background is. So courses about materials for implants, and also courses about biological materials. I also teach in our first year design course, Design Nature. I still do some research in biological materials, but the bulk of my research is on the engineering education experience. I came to Olin because I had a long-standing interest in, as well as doing research, in teaching, but also in academic governance. And so when I heard that there's this new college being built, I knew that there's an opportunity for me to do really interesting things. One thing that's really wonderful about Olin is that our students are really deeply engaged in learning for its own sake. And so it means that they come to classes ready to be engaged, ready to work on things. And this isn't an accident that they're like this. They're this way because of the culture that we've developed at Olin around learning. Everything from the emphasis on design to doing pass no credit in the first semester. They really come to Olin knowing that they're here to really engage with their education, and they carry that all the way through. So what it means is that we have an enormous amount of flexibility in the types of things that we do with our class, and it enables us to give them a lot of freedom in terms of what they do. So it means that we can be really more mentors or coaches rather than being the person standing at the front of the class with all the answers. And so that leads to our students being really involved and really engaged, really motivated. They get to work on projects that they're interested in, and they get to explore really deeply on their own. And so I see our role as really supporting that and scaffolding that process rather than being the person who tells them what to do. Our students have a lot of different opportunities to shape their own learning experiences, including projects and classes, but also up to and including their curricula and their programs. So all of that really fosters a culture of students taking responsibility for what they're going to learn, why they're going to learn it, and it gives them some groundwork for moving on and making decisions about what they're going to do after they graduate.
Modeling simulation is one of the classes that every student takes in their first semester at Olin, and using the models to do something useful.
They start off by showing us this map. Basically they say, this is your environment, this is your real world. We're going to take one part of this world and abstract it, simplify it down to the necessary components, and then we're going to make a mathematical model of this. After we make the mathematical model in MATLAB, we analyze the data and we tie it back to the real world to see how it actually fits in. So that's how the class starts.
Modeling and simulation, like a number of classes at Olin, is taught in a studio setting, which is sort of inspired by the way that people often work in a design studio or an architecture studio. The idea is that students have a space that they're working in. They're working either in teams or working individually, but they're working on something at their own pace with the instructor acting much more as a coach and as someone who's giving critiques and helping them think about things than someone who's standing in front and telling them what the answer is. What our hope is that coming out of this class, they will instead be able to look at real physical situations and say, okay, I can identify 2 or 3 ways that I could model that, because that idea of actually using the sort of ideas in mathematics and science in order to do something where you're actually making an argument to someone isn't something that's emphasized in high school. Honestly, it's not something that's emphasized very often in college, but at the end of the day, that's what it's for.
It's not just math, it's not just science, and it's not just programming. It's a process, it's modeling, and the whole process is to do work. I remember halfway through the semester, there was a survey sent out, how is ModSim going? And the class changed after that, the feeling of it changed. And for professors to really have that type of open feedback, it really helps. It really helps. There's no other way that innovation could occur if they didn't have that type of communication.
My favorite thing about teaching at Olin is when class ends and you have to tell everyone that class ended. For students to be engaged in that way, where they actually forget time and they're sort of in the flow and they're excited about what they're doing and working on it hard enough that they forget to watch their watches, that's pretty cool. I like that.
Design Nature is a first-year introductory design course for engineering design. We call it a bio-inspired introduction to engineering design. And in that course, students are learning how to practice engineering design, how to realize products and working prototypes, starting from ideas and from aspirations. In that course, we take a bio-inspired approach, so we look to nature for inspiration and for insight on how mechanisms, devices, things work, how energy and materials are used effectively and wisely. But we're also learning engineering design process, steps to take in starting with ideas and how to systematically work all the way to working prototypes. And they do that through 2 projects. One is the well-known Hopper project, where students study hopping insects in nature, and then they ultimately design their own hopping insects. In the second project, they work in teams, and they now have a budget, they have a schedule to set, and they're starting to take more control of the process and define it for themselves. And in this project, they're inspired from an animal in nature to create a toy for fourth graders. And at the end of the project, the fourth graders actually come and experience the game designs that the students come up with and evaluate how well the Olin students have done.
I think one of the big times was when Jay and Insong went out and they were able to get the mechanism for when the head moved back that the llama squirted, so that was really exciting because we knew our game would work. Another really cool time is when we all went together to Harvey's Hardwares and we bought the stuff for the llama and then started building it. And it was really a cool time to actually see the llama become a much bigger thing.
CADing, sewing, teamwork, like talking with each other, just communication in general, making iCals, coming to meetings on time.
Group emails,
actually going out, working together, starting from nothing and then finishing with this last product that we successfully had all the children play.
Yeah, I couldn't be happier with the group. We all worked together really well and things got done on time. I think that's one of the reasons our project was so successful, but because of just how well we worked together. So everyone took a part in making the llama and has something to be proud of.
My name is Maya Bittner. I graduated in 2011 from Olin College. I was originally part of the class of 2010, but I took a year off. And I'm the CTO and co-founder of Roxbox. Roxbox is a membership service. Our customers have a membership with us and they pay by the month. And what that gives them access to is our huge library of designer jewelry. And our stylists will select 3 of these pieces for one of our members to wear at a time. So they get this set of 3 pieces and they can wear it as long as they want. So it's like Netflix in that way, is that you can keep it until you get bored of the pieces. Just our daily operations, the scale is pretty large. Every day we receive from 100 to 300 shipments. That's about 700 pieces of jewelry that we have to check back into inventory, sterilize for the next customer, and clean up. And then the same, we ship outbound. So every day we're shipping between 100 and 300 packages to our customers. Over 1,000 pieces of jewelry that we're processing through the office here every day. At Roxbox, for a long time, I was the only engineer here and the only dev. So it was necessary that I have to be able to communicate different technical constraints and different parts of the engineering world to people who weren't engineers. And that's the thing that I definitely see when I think of Olin students in general, is that they're the people that are able to communicate across disciplines. They're able to connect with people and they have hobbies and interests that are outside of engineering. They don't live in this silo of engineers. The skills from working in a team are just so applicable here. And there are all these different components about someone that make someone good at working in a team. And I think about Olin's feedback culture often and how proactive they are both about giving feedback and asking for feedback. When you're working in an early stage startup, as a founder or as an employee, so much of that is doing things that you've never done before, and I think that that's the thing that Olin really prepared me to deal with. When Roxbox was really small and it was just 2 or 3 people, there wasn't anyone I could ask for help or say, tell me how to deal with customs when you're manufacturing things in China and shipping them here. I just had to learn how to do it and fill out the paperwork and do some research and teach myself. And so I think that's really the biggest thing, in that that's why Olin lends itself really well to entrepreneurship, is because when you're starting a company, you're never going to know everything that you need to know to do something ahead of time. You're just going to have to learn it on the fly.
SCOPE is Olin's year-long senior capstone program taken by most Olin students, where they work on a real-world problem presented to us by industry sponsors. SCOPE is a true capstone for our students. It's where they get to synthesize everything they've been learning over the past 4 years.
The project that we're working on for Boston Scientific is improving early detection of lung cancer. And the reason that this is so important is that lung cancer is one of the worst cancers for 5-year survival.
In choosing the projects, we really focus on projects that are going to have an impact on our sponsors. So we really work hard to frame the projects in collaboration with sponsors and also faculty to make sure that it's going to be a great experience for students, but also something that will really make a difference for the sponsors.
We don't have any teachers for SCOPE. It's all determined by us. So at the beginning of the year, once our scope team was formed, once we found out who was on our team, one of our first meetings was determining different roles on the team. So we have a safety and ethics officer, a communications officer, a business officer, and a project manager on our team. And I'm the project manager, so my role is to help guide the team on a long-term scale to make sure we're meeting our goals.
In the 9 years that Scope has been running, Boston Scientific has actually sponsored over a dozen projects. They have been a really wonderful partner. They really get Olin, they really get Scope. One of the things that we find is very valuable to our sponsors is that on Scope projects they get to keep the intellectual property. And so our students are educated about keeping things confidential.
This is a great opportunity with a young group of engineers with really wide open set of eyes to look at a problem probably differently than some of the engineers that have been around a while.
After they meet with their sponsors, the students develop a project plan, which is a longer and more detailed statement of the problem that they'll be working on and the approaches they'll be taking. And then they spend most of the first semester doing a lot of background research and starting to prototype for their project.
We want to be able to find lesions in distal regions of the lung, so far away. So we were cutting off some of the lower lobes to see what the lungs look like at points further away.
We took a problem statement about lung cancer, looked at lots of different ways we could solve it, picked one, went through with it, tested it, made sure it was effective, and then developed our own prototype that could do this. And now we're ready to hand that off to Boston Scientific.
You know, if this goes well and if Boston Scientific continues with this project, it's actually going to, save people's lives. And if you're able to detect lung cancer earlier, like, that's pretty incredible to be a part of a project that's actually going to have this positive impact on the world.
They're very creative individuals. They like to create solutions to problems, which makes them good engineers.
Affordable Design and Entrepreneurship is a joint program between Olin College and Babson College. And in that program, we strive to educate students to be leaders in addressing poverty around the world for people living in low income and resource poor situations. In ADE, students work in teams of about 7 or 8 students, and they're working on social ventures to address needs in areas of the world that are both in the United States and abroad, anywhere there are contexts of poverty.
ADE is special because the projects transfer from semester to semester, year to year, and we get to have this first chance at this project. Energy is really important in developing countries, and that is what people really need, because right now they're paying a lot more for energy than we do. And so we are trying to help them have cheaper and more reliable sources of energy to combine with their other diesel generators and the grid that they have, because those aren't reliable, but in conjunction with our project, which is a concentrated solar power generator, they can have more reliable energy all the time. ADE is reserved for seniors, maybe second semester juniors. And I think it's really important that it is that way, because this is meant to be a capstone project, a capstone design project, and it uses all of the things that I've learned so far. It uses the very first semester when we did Design Nature, and we learned about design and kind of how to CAD and use 3D modeling software. And it uses even the math that we've taken, and I've taken lots of physics, thermodynamics, fluid dynamics, and it takes all of that and expects you to know and be able to use and apply that in a way that's really real. Our project has kind of life or death consequences.
So our students are passionate about making a difference in the world and engaging to improve the lives of people living in poverty. But they don't necessarily have the skills to do that, and the ADE program makes it possible for them to both have the experience to understand what poverty is like, what it's all about, and to really appreciate what it means to create social ventures and to work in contexts where delivering products and services is very difficult, but also just different than what they have experienced in their lives.
Principles of Engineering is a course that kind of introduces engineers to the idea of systems integration, building a functional thing that works from start to finish. So it starts as a series of lab classes where you build more and more complex systems with a kind of shared fundamental platform. In our case, this year was the Arduino. And you kind of learn how to add things onto it and learn how to build complete systems. And then a third of the way through the course, it's okay, well, we've taught you everything you need to know. Go pick a thing, design it, and build it for 2/3 of the class and create some electromechanical system that you find inspiring and take it all the way to the end.
Okay, so my team is making a robot that plays guitar. So we have a platform and our guitar in the back. I am working on the strumming system, so at the sound hole. So each of these will pluck each one of these will pluck a string. And so we have 2 sets, so we have all 6 strings here.
I'm kind of in charge of getting all of the power and the electricity to everything. So all these solenoids have 2 wires that have to get routed to the appropriate places.
A class like this introduces you to all of the kind of non-design aspects of getting a project done, right? You run into, wiring motors, reading sensors, dealing with an entire system that has a computational, electrical, and mechanical aspect to it, and you're mixing them together for the first time.
So we are building an auto-targeting sprinkler. So basically the idea is you walk by it and it turns around and shoots you with water.
So I've been working on some of the coding stuff. So what we're doing right now is there's a Raspberry Pi over there somewhere, or over here, with a camera module. And we're trying to get it to work so that the image processing will run nice and swiftly on that tiny computer, which is running Linux like a real computer, except you have to there are a lot of challenges that go along with coding something like that, a tiny microprocessor. So we're working on making that interface work right now.
I think the key learning experience of this class is really taking something from start to absolute finish. So this is really what gets your feet wet and what introduces you to the kind of whole design cycle for a given product.
It's a nice way to find the overlap between working with what you like to do and learning what everyone else around you likes to do and working together as a combination.
Yeah, it's the first time that we're really putting all the pieces together of the different things that we've learned. It's awesome.